Okay, let us proceed now for the isobaric process. Isobaric process. Okay, when you say isobaric process is an internally reversible constant pressure process of a working substance. Okay. Under the PB, this one, pressure is constant. When you say pressure is constant, your P1 is the same as P2. Okay. Under the PV plane, pressure volume plane, as the volume increases, the pressure remains constant. Okay. Even the volume decreases, the pressure remains constant. This one is your V1. You have V1. Then this one is your V2. Under the TS plane, temperature entropy. Okay. As the temperature increases, the entropy also increases. This one is TS plane. This one is your S1. This one is your S2. T2. And this one is your T1. Okay. Now the relationship. A. Since your pressure is constant, we have T2 over T1 is equal to V2 over V1. Again, the temperature here should be absolute temperature. Letter B for the non-flow work. That is equal to the integral of P dV with the limits from 1 to 2. Therefore, we have, when we integrate that, we have P V2 minus V1. Okay, letter C. We have delta U is equal to mCV T2 minus T1. Okay, letter D. We have heat, which is equal to mCP T2 minus T1. While for letter E, delta H, which is the change in enthalpy, is equal to mCP T2 minus T1. For the change in entropy, delta S is equal to mCP ln T2 over T1. For the steady flow work, for the steady flow isobaric, steady flow work is equal to negative change in kinetic energy plus change in potential energy. Change in potential energy. But if the change in potential energy is equal to 0, if the change in potential energy is equal to 0, the steady flow work is equal now to negative change in kinetic energy. Okay. Steady flow work is also known as the negative integral of V dP with the limits from 1 to 2, which is equal to plus the change in kinetic energy. Okay. If this one is 0, therefore, steady flow work is the same is equal to negative change in kinetic energy. If the integral of V dP with the limits from 1 to 2 negative is equal to 0, thus delta S is equal to negative change in kinetic. Okay, example problem.
Miss, nakamute po ata kayo.
Okay, example. A cylinder with a movable piston holds 0.2 pounds of hydrogen initially with a volume of 1.5
Hindi
cubic
din daw
feet.
po kayo marinig.
Okay, now we have 1.5 cubic feet at a temperature of 1,400 degree Fahrenheit. Then the volume expands to 3.0 cubic feet, while the gas pressure remains constant. Okay, letter A, what is the initial gas pressure? Letter B, what is the final gas temperature? Letter C, determine the change of entropy. Okay, for the system, hydrogen inside a cylinder with a movable piston. Given state 1, you have your V1 is equal to 1.5. 1.5 cubic feet, T1 is equal to 14 degree Fahrenheit, 1,400 degree Fahrenheit plus 460 is equal to 1,860 degree Fahrenheit. Mass is equal to 0.2 pounds. 0.2 pounds instant. Process. Since the gas pressure remain constant, therefore pressure is constant, therefore that is under isobaric process. Okay, state 2, V2, 3 cubic feet. 3.0 cubic feet. Okay, for the figure, we have the figure on state 1 piston on the piston head, piston rod, the hydrogen. Okay, the volume 1 is 1.5 cubic. State 2, okay, volume is 3. Hydrogen. Okay, volume 2 is 3.0 cubic feet. Now for the solution, letter A. Okay, the value for the constant value of the gas constant for the hydrogen is equal to 766.54 foot-pound force per pound mass degree Rankine or Rankine. Formula, we have P1. V1 is equal to MR T1, where P1 is equal to MR T1 over V1, which is equal to mass is 0.2 pounds, 0.2 pounds times R 766.54 pound force, foot-pound force. Foot-pound force, foot-pound force per pound mass. Okay. Then T1 is 1,860. 1,860 degree Rankine or Rankine over V1. This will be 1.5 cubic meter. Cubic feet. Pound mass, cancel. Degree ranking, and then you have square. Okay, therefore, your P1 is equal to 190,101.92 pounds per square feet. Convert into inches, inch square, foot square. Okay. 1 foot square is equal to 144 inch square. Okay, therefore, P1 is equal to 1,320.15 pounds per square inch. Okay, next, letter B. Letter B, constant pressure. Therefore, the next one we are looking for final temperature. Okay, final temperature. Therefore, we have V2 over V1 is equal to T2 over T1. Okay, from this equation, we can say that your T2 is equal to T1 V2 over V1. Okay, T1 is equal to 1,860. 1,860. 1,860 degree Rankine times V2 is 3.0 cubic feet over V1 1.5 cubic feet. Cancel. T2 is equal to T2 is 3,700. 3,720 degree. Okay, letter C. Okay. Cp of hydrogen is equal to 3.419. This one is the constant value for the specific constant pressure specific heat of hydrogen. 3.419 BTU per pound mass degree Rankine. Okay. The requirement for letter C is the change of entropy. Therefore, we have delta S is equal to mCp ln V2 over V1. And delta S is equal to 0.2 pound mass times Cp is 3.419 BTU per pound mass degree Rankine. Ln V2 is 3.0 cubic feet over 1.5. Cancel, pound mass, BTU per degree Rankine. Okay, delta S is 0.474 BTU per liter.